Can we start the class, sir?
Start, madam.
Can you all make there's a lot of disturbance in the background?
Yeah.
Madam, can you please guide them?
Javed, sir?
Yeah, madam. Hello.
There is a lot of disturbance, sir, in the back. Can you please mute?
Okay, sir.
Okay,
Srikanth, sir?
yes. So,
Please start the class, sir.
okay, ma'am. Partial fractions, class number 3. Okay. So in the last class, we have discussed. In the last class, what did we discuss? In the last class, we discussed about rule 2, which is repeated linear factors, and rule 3, which is non-repeatable irreducible quadratic factors, and we have discussed about rule 4, which is repeatable irreducible quadratic factors, and we've done few problems based on these rules. Okay, and in today's class we shall discuss about partial fractions of f of x by g of x when f of x by g of x is an improper fraction. So far, we have been dealing with the problems based on proper fractions and resolving them into partial fractions. Now, to find partial fraction, so PF I'm writing in short, which is nothing but partial fraction. To find partial fraction of f of x by g of x when f of x by g of x is an improper fraction. To find partial fraction of f of x by g of x when f of x by g of x is an improper fraction, two cases arise. Two cases arise. One is when the degree of f of x is equals to degree of g of x. So when degree of f of x is degree of g of x, it's an improper fraction. And one more cases, second is when the degree of f of x is greater than degree of g of x. So we shall discuss these two cases and do some problems based on these two cases. So improper fraction. What is an improper fraction? When you say a rational fraction is an improper fraction, when degree of f of x is equals to degree of g of x and degree of f of x is greater than degree of g of x. In other sense, what is a proper fraction? When degree of f of x is less than degree of g of x. We have done already many problems based on that, and we have defined rules based on that. Okay, so now whenever you have an improper fraction, you have to reduce it to a proper fraction by these two cases. We shall discuss these two cases one by one. Okay, case 1. If degree of f of x is equals to degree of g of x, then by division algorithm, f of x by g of x can be expressed as f of x by g of x is equals to k plus r of x by g of x, where r of x by g of x is a proper fraction, which can be resolved into partial fractions using the rules which we have defined. And k, a constant value, k is nothing but coefficient of highest power of x in numerator divided by coefficient of highest power of x in denominator. For example, we have x cube divided by 2x minus 1 into x minus 3 into x minus 2. Take for an example. This can be expressed as k plus a by 2x minus 1 plus b by x minus 3 plus c by x minus 2, where k is equals to coefficient of highest power of x in numerator denominator divided by coefficient of highest power of x in denominator. So what is the coefficient of the highest power of x in numerator? It's 1. And what is the coefficient of highest power of x in denominator? If you multiply all these, you'll get a cubic expression, and the coefficient will be 2. It will be 2x cubed. 2x into x will be 2x cubed. Therefore, coefficient of highest power of x in denominator will be 2. So we can write this as, the numerator it is 1, and in the denominator it is 2. So k will be half. So here you're going to substitute half plus, and then you can resolve into partial fractions. Okay. So this is case 1. Okay. Case 1, it's quite simple. When degree of f of x is equals to degree of g of x, it can be expressed in k plus rx by g of x, where rx by g of x is a proper fraction. Okay, and k is the value constant, which is coefficient of highest power of x in numerator and coefficient of highest power of x in denominator. Now we shall discuss case 2. Case 2. What is the case 2 we've defined? If the degree of f of x is greater than degree of g of x. So these are the cases for an improper fraction. Then if degree of f of x is greater than degree of g of x, then by division algorithm, f of x by g of x can be expressed as f of x by g of x is equals to q of x plus r of x by g of x, where q of x is quotient and r of x is remainder. R of x is remainder. When f of x is divided by g of x. We'll take an example and see how it goes. For example, x to the power 4 divided by x minus 1 into x minus 2 can be expressed as x square plus 3x plus 7 plus 15x minus 14 divided by x minus 1 into x minus 2. We get this by long division process. By long division process, where if you look at this fraction, it is a proper rational fraction. Proper rational fraction, which can be resolved into partial fraction. Clear? So now, if you look at this one, we also know that you have to remember this. We know that you've already learned this in your previous school or previous classes. Dividend is equals to divisor into quotient plus remainder, or this can also be written as dividend divide throughout by divisor, dividend by divisor is equals to quotient plus remainder divided by divisor. Clear? So this is of the form, like if you look at the fraction, it is f of x by g of x is equals to q of x, where q of x is the quotient, plus r of x by g of x, where r of x is the remainder. Okay. Now we shall do problems based on these two cases. Let us take one problem. In the previous class, we've done number 3. We'll consider this as 4. Resolve x square divided by x minus 1 into x minus 2 into partial fractions. Now let us see the solution for this one. So if you look at this rational fraction, first you have to check whether it is a proper rational fraction or improper rational fraction, isn't it? So if you look at this one, the degree of numerator is 2, and if you multiply these and resolve, you are going to get a quadratic expression, and the degree is 2. The degree of numerator and the degree of denominator is same. The degree of numerator is equals to degree of denominator. So therefore, the given fraction x square divided by x minus 1 into x minus 2 is an improper fraction. Is an improper fraction. Why? Since degree of numerator is equals to degree of denominator. How do you proceed for this one? This can be expressed as, therefore, x square by x minus 1 into x minus 2 can be written as k plus a by x minus 1 plus b by x minus 2, where we have already defined k. What is k? Coefficient of highest power of x in numerator divided by coefficient of highest power of x in denominator. So what is the coefficient for this one? It is 1. In denominator you have x square, and here also it is 1. Therefore, this is equals to 1 divided by 1. So the value of k is 1. So this expression can be written as 1 plus. We shall write that. Therefore, x square divided by x minus 1 into x minus 2 can be written as 1 plus a by, because value of k is 1, a by x minus 1 plus b by x minus 2. Let us consider this as equation 1. Now you have to consider the LCM for this. So this implies x square divided by x minus 1 into x minus 2. Simplify further. What's the LCM? X minus 1 into x minus 2. And this can be written as x minus 1 into x minus 2 plus a into x minus 2 plus b into x minus 1. Okay, these two terms get cancelled in the denominator. So this implies x square is equals to x minus 1 into x minus 2 plus a into x minus 2 plus b into x minus 1. Okay, now we shall find out the values of a and b. Okay, so what are the factors you have? X minus 1 and x minus 2. Let us consider this equation as two. Fine. Okay. What are the factors you have? X minus 1 and x minus 2. So if you equated this to 0, x is equals to 1 and x is equals to 2. Okay. So we shall write that equation 2 again. From 2, what do we have? X square is equals to x minus 1 into x minus 2 plus a into x minus 2 plus b into x minus 1. So we shall write this again. X square is equals to x minus 1 into x minus 2 plus a into x minus 2 plus b into x minus 1. Now put x is equals to 1 in the above equation. We have called that as equation 2. Let us see what are we going to get. 1 square is equals to 1 minus 1 into 1 minus 2 plus a into 1 minus 2 plus b into 1 minus 1. This implies 1 is equals to 1 minus 1, 0, plus a into 1 minus 2 minus 1 plus b into 0. So this implies minus a is equals to 1. So this implies a is equals to minus 1. Now we'll substitute x is equals to 2. Put x is equals to 2. Put x equal to 2 in equation 2. What do you get? 2 square is equals to 2 minus 1 into 2 minus 2 plus a into 2 minus 2 plus b into 2 minus 1. So this implies 2 square is 4, and on the RHS 2 minus 2 is 0, 2 minus 2 is 0, plus 0 plus b into 2 minus 1 is 1. So what are we getting? B as b is equals to 4. We got the values of a and b. Now substitute these values in equation 1. Equation, what is the equation 1? X square by x minus 2, x minus 1 into x minus 2 is equal to 1 plus a by plus b by. So you have to substitute the values in equation 1. Substitute the values of a and b in equation 1. What are we going to get? Therefore, x square divided by x minus 1 into x minus 2 is equals to 1 plus value of a is minus 1 divided by x minus 1 plus 4 divided by x minus 2. What is this? 1, we can write this as 1 minus 1 by x minus 1 plus 4 divided by x minus 2, and solve. This is a problem based on case 1. So we shall do one more problem based on case 2. Let us consider this as number 5. Resolve x cube divided by x minus 1 into x minus 2. So we will consider this as x plus 2 into resolve into partial fractions. So if you look at this one, first you have to say whether, check whether the rational fraction is a proper or an improper fraction. If you look at this one, clearly the degree of numerator is 3, and in the denominator x into x, x square. So degree of numerator is greater than degree of denominator. So it is an improper rational fraction of case 2. Okay. Now we shall see the solution. The given fraction x cube by x minus 1 into x plus 2 is an improper rational fraction. Why? Since degree of numerator is greater than degree of denominator. Fine. So now let us follow the procedure, case 2. So now we'll consider this. Now, what is this? X cube by x minus 1 into x minus 2 can also be written as solve the denominator or expand the denominator. What are we going to get? X square plus x minus 2. So this is of the form f of x by g of x. Okay. So by long division process, by long division process, x square plus x minus 2 and x cube. This is the dividend and the divisor. You have to divide these using long division process. Let us solve this one. So first you have to multiply this with x. So what are you going to get to multiply with x? X square plus x minus 2 into x. X cube plus x square minus 2x. So we're going to write this. We're going to write x cube plus x square minus 2x. Now we are going to put minus here minus, and here plus. These two terms will get cancelled and it will be minus x square plus 2x. Again with minus 1. X square plus x minus 2 into minus 1. What are you going to get? Minus x square minus x plus 2. We'll substitute here. Minus x square minus x plus 2. So this will be plus, and this will be plus again, and this will be minus. So what is it? These two terms get cancelled, and 3x minus 2. So this is the remainder r of x. This is the quotient q of x. So what you can write? Therefore, x cube by, we have done this one using long division process and we got the quotient and remainder. So this can be written as x minus 1 plus 3x minus 2 divided by x minus 1 into x minus 2. Since f of x by g of x is equals to q of x plus r of x by g of x. So we'll write this as equation Roman number 1, and we'll try to simplify further. We have to consider this one. This is a proper fraction, and we have to resolve this into partial fractions. Okay. Now, now consider three x minus 2 by x minus 1 into x minus 2 is a proper fraction. Since degree of numerator is less than degree of denominator. So we shall resolve this into partial fractions. Therefore, 3x minus 2 divided by x minus 1 into x plus 2 can be expressed as a divided by x minus 1 plus b divided by x plus 2. Let us consider this as equation 1. We shall simplify this one further by taking LCM. So 3x minus 2 divided by x minus 1 into x plus 2. What is LCM? X minus 1 into x plus 2. So in the numerator we can write as a into x plus 2 plus b into x minus 1. The denominators will get cancelled. So what we can write this further? 3x minus 2 is equals to a into x plus 2 plus b into x minus 1. b into x minus 1. So we'll consider this as equation 2. So what are the factors you have? What are the factors? X minus 1 and x plus 2. We shall substitute these factors and we have to find out the values of a and b. A and b. Okay. What are the factors? X minus 1 and x plus 2. So if this is equals to 0, x is equals to 1 and x is equals to minus 2. Okay. So we shall write down this equation 2 again and try to simplify. From 2, what is that we have? 3x minus 2 is equals to a into x plus 2 plus b into x minus 1. Put x is equals to 1. In equation 2. In equation 2, what are we going to get? 3 into 1 minus 2 is equals to A into 1 plus 2 plus B into 1 minus 1. So this implies 3 minus 2 is equals to A into 3 plus B into 0. So this implies 3 minus 2 is 1, which is equals to 3A. So what do we get? 3A is equals to 1, or A is equals to 1 by 3. A is equals to 1 by 3. We'll try to find out the other value by substituting other factor. Put, what is the other factor we have? Put x is equals to minus 2 in equation 2. Okay. 3 into minus 2 is equals to A into minus 2 plus 2 plus B into minus 2 minus 1. So this implies minus 6 minus 2 is equals to A into 0 plus B into minus 3. So this implies minus 3B is equals to minus 8. This implies B is equals to 8 by 3. Minus and minus will get cancelled on both the sides. We got the values of A and B. Substitute in equation 1. Substitute the values of A and B in equation 1. Substitute the values of A and B in 1. So what do we get? 3x minus 2 by x minus 1 into x plus 2 can be written as, what is the value of A? 1 by 3 divided by x minus 1 plus 8 by 3 into divided by x plus 2. Now, so we'll consider this as 3. Substitute this equation in 1, which will be the end answer. What do we get? X cubed by x minus 1 into x plus 2 is equals to x minus 1 plus 1 by 3 into x minus 1 plus 8 by 3 into x plus 2. Okay, so this is the end of this problem and the end of this chapter. We shall do some assignment problems. I'll assign some problems for today's homework. Today's assignment. Resolve the following into partial fractions. First problem, x cubed divided by 2x minus 1 into x minus 1 whole square. Second, x cubed divided by x minus 8 into x minus b into x minus c. Last one. Third problem, x to the power 4 divided by x minus 1 into x minus 2. Okay, thank you, everyone. Thank you, madam.
Thank you very much, sir. Dear children, with this we have finished our chapter partial fractions. Tomorrow we shall start a new chapter, permutations and combinations. Thank you all.